Let's see the example problems on temperature stresses. First problem is two parallel walls 8 meter apart are stayed together by a steel rod of 20 mm diameter passing through metal plates and nuts at each end. The nuts are screwed up to the plates while the bar is at a temperature of 400 Kelvin. Find the pull exerted by the bar after it has cooled to 300 Kelvin. And first condition is if the ends do not yield, and second condition is if the total yielding at the two ends is 5 mm. Take the alpha value for the steel is 12 into 10 to the power minus 6 per Kelvin, and E value is the 2 into 10 to the power 5 Newton per mm square. So let's see the solution. So first to write down the given data. So here it is given the length of the wall, let consider capital L is the 8 meter. So this is we have to express in the mm because E value is given in Newton per mm square. So length of the wall L equal to the 8000 mm, and it is given the diameter of the steel rod, that is the 20 mm. Then cross sectional area of the steel rod is the, let consider capital A, equal to pi by 4 20 square, that is the 314.16 mm square. So and the temperature fall, so initially it is the 400 Kelvin, then it is the cool down up to the 300 Kelvin. Then the change in temperature, let consider capital T, equal to 400 minus 300 equal to the 100 Kelvin. So then we have to determine the pull exerted by the bar. Condition is if the ends do not yield. Similarly, we have to find the pull exerted by the bar if the walls yielding by 5 mm. So and he given the alpha value is the 12 into 10 to the power minus 6 per Kelvin, and E value is the 2 into 10 to the power 5 Newton per mm square. So let's we have to see the pull exerted by the bar. So it is the force exerted by the bar. First condition, if the ends do not yield. So we know the formula. If the ends are do not yield, so thermal stress sigma T equal to the E alpha T. So here it is given, the E value is given, alpha value is given, and also T value also given. Then substitute all these values in the alpha T equation. Then alpha T equal to E value 2 into 10 to the power of 5, alpha value 12 into 10 to the power of minus 6, and T change in temperature 100. Then alpha T value will become the 240 Newton per mm square. So now we know the stresses due to the temperature changes sigma T. Then we can be determine the force. Force is nothing but stress into the cross sectional area. So force equal to the, that is the pull exerted by the bar, P equal to the sigma T into the cross sectional area A. So that is 240 into 314.16. So value is the 75,398.4 newtons. It is the 75.398 kilonewtons. Okay, next we have to see. Next we will look for the second condition. If the wall yielding by 5 mm. So in general we are using the notation is for yielding small a. So here yielding value small a value is given the 5 mm, and we know the formula for the sigma T. If the yielding is given, that is sigma T equal to the alpha TL minus A into E by L. So in the data it is given the all the values of the alpha, T, L, A and E. Then substitute all these values in the sigma T equation. Then temperature stress, that is the sigma T equal to 12 into 10 to the power of minus 6 into 100 into 800 minus 5 into 2 into 10 to the power of 5 divided by 8000. So if you solve this one, so we will be get alpha T equal to the 115 Newton per mm square. So next we have to see the another problem. A rod is 2 meters long. So it is given the length of the rod. So that is the capital L, 2 meters. So I have to express this is in the centimeter because so E value is given in the centimeters. That is E equal to the 1 into 10 to the power of 6 kg per centimeter square. Then find the expansion of the rod. So how to determine the delta T value when the temperature is raised to 80 degrees centigrade. So initially it is the 10 degrees centigrade, then changed to 80 degrees centigrade. So then the change in temperature capital T is the 70 degrees centigrade. If this expansion is prevented, then find the stresses in the material. So how to determine the stresses in the material and expansion is prevented. So expansion is prevented is nothing but there is a no yielding. So how to determine the sigma T value and condition is there is no yielding. And it is given the E value 1 into 10 to the power of 6 kg per centimeter square and alpha value is given the 0.000012 per degree centigrade. Okay, so let's see the solution. So we know the formula for the deformation of the bar due to the change in temperature, that is the delta T equal to the alpha TL. So here it is given the alpha value and T value and L value. Then substitute. So alpha T will become the 0.000012 into 70 into 200. It is the 0.168 centimeter. So next we have to determine the stresses. So that is the sigma T. So we know the expression for the sigma T equal to the E alpha T. So we know the E value, alpha value and T value. Then stresses value will become that is a sigma T equal to the 1 into 10 to the power of 6 into 0.000012 into 70. Then alpha T value becomes the 840 kg per centimeter square. So these are the example problems for the temperature stresses, and thank you.